Hello, my name is Pavlo Shymaniuk, and I would like to present to your attention a report on the topic calculation of electricity losses using neural networks for retrospective data with the presence of anomalous value. In the electricity market of Ukraine, distribution system operator and transmission system operator are required to purchase electricity to cover losses in their own network. This implies that the expenses associated with the purchase of electricity losses impact the final price of electricity consumers through the tariff of DSO and TSO. As of today, electricity losses of distribution network of Ukraine can reach 20%, while in the most European countries this loss indicator within the range of 4 to 6%. Additionally, sharp changes of the topology of electrical network lead to an increase in the forecast error of losses and the single time series and reduce as a single time series and reduce the efficiency of network management. Considering the necessity of load forecasting, the idea of using the forecasting methods to determine electricity losses in electrical network has been proposed. In this regard, artificial neural networks are proposed as forecasting method, recognized as effective forecasting models. It is important that the presence of reliable load forecasting results in the nodes of the calculation scheme of different forecasting horizon. In addition, the reducing cost of the purchase of electrical energy allow to increase the efficiency of managing the model of electric network, in particular with the use of smart grid system, which is relevant for Ukrainian in modern condition. The realization of the set goal involved solving the following task, which you can see on this slide. Two approach to forecasting losses were developed to test the effectiveness of losses forecasting. First approach is forecasting the load of each node separately, followed by consolidation of data and the calculation of losses based on forecasted data. Second approach is calculation of electricity losses followed by subsequent forecasting of losses. For modeling the electrical network for loss calculation, the SIGRE medium voltage network was used as the basis of the test power system. This system consists of the two transformers with the capacity of 40 megavolt amperes with 110 and 20 kilowatts, 15 nodes, 18 load sources with two sources removed to align with retrospective data, 14 lines including 12 cable lines and 1 overhead lines, and switch. All elements used in this network are elements of Panda-Power library. Since this network is built on the basis of the real European network, it differs significantly in the term of load composition and network parameters of the Ukrainian network. Therefore, to ensure the proper functioning of the losses calculation algorithm, the calculation scheme was adapted to use the available retrospective data. The data for forecasting and calculation of electrical power losses, the data from the one of the Ukrainian DSO was used. The data of which includes 16 load for the period from 2017 to 2019 with 30-minute discreteness. the total value of the data amounts to 48,048 values. After conducting preliminary data analysis, it was differently identified that the data contains missing value and anomalous value that significantly divided from normal values. To identify and replace missing values and anomalous value, our two-stage verification algorithm was applied to use the dbScan clustering method, which is presented in this slide. The next slide presents the result of determining the losses of electricity using the different forecasting method. In figure 4 shows a graph of half-hourly losses per day using different forecasting methods. And figure 5 presents a graph of half-hourly losses for monthly period. The map function was used to assess the accuracy of presented approach. This slide shows that the forecasting errors of electricity losses. Having conducted forecasting and losses calculation using all approach, we observe that generally all forecasting with subsequent losses calculation method have a lower error in losses. It is also worth nothing that the use of data analyze method for detecting and replacing anomalous value allow for an improvement in forecasting result. The obtained research result are component of the data preparation work of the smart grid model of operational management of distributional network based on artificial intelligence methods. This model is being developed by the author of the publication with the framework in the joint Ukrainian-Lithuanian project. In 24-25 the result of the study demonstrates that the proposed method for short-term forecasting of aggregated electricity losses value in the power grid based on retrospective data using deep learning artificial neural network allow to increase accuracy in determining losses without performing the calculation compared to existing method. Additionally, methods of the short-term forecasting of the node load based on the deep learning artificial neural network have been proposed. This allows for an increased accuracy in determining and calculated values of losses in the power grid by incorporating forecasting node load values during the calculation. The result of forecasting electricity losses show that the application of the data verification method and forecasting methods allow to reduce the magnitude of losses compared to forecasting actual losses data with the expecting anomalous value. Conducting additional data analysis to identify and replace anomalous value has improved the accuracy of forecast for both node load and electricity losses. For the forecasting error of losses using artificial neural network allow obtaining a MAP error within 3.29% for the forecasted verified data of the node load used of loss calculation. Then the forecast of verified losses data have an error of 20.24%. The loss of the unverified data is 20.08%. The use of forecasting methods is most effectively demonstrates that when predicting verified data, node load data use for loss calculation. Based on this presented result, In future studies, it is planned to improve the methods of forecasting and calculation of electricity losses, in particular with the possibility of using additional factors. In addition to obtain more accuracy value of the losses, it is necessary to build on test network based on real scheme of electrical network. For that moment I am done. Thank you for your attention.